on question 31, there are multiple ways to solve this, of course. Some of them are taking points. This is the method that I prefer because it's more concrete than the others. So we're going to start off. This is basically our A matrix. We're just going to find its eigenvalues and eigenvectors. So -3 minus lambda, 1, 2, -2 minus lambda, close bracket. Find the eigenvalues. So it's -3 minus lambda, close bracket, -2 minus lambda, minus 2. Don't forget this is a minus. Minus 2 is equal to 0. This thing should equal to lambda squared is equal to plus 5 lambda plus 6 minus 2. This should equal to 4. You should be able to break this up into two parts, so lambda plus 4 and lambda plus 1. So the first eigenvalue is equal to -4. The second eigenvector value is equal to -1. So now we're just gonna sub it in and find the equation for it. Here's what I like to do: is basically we're gonna take this part as the x, this is y, and then solve. Here I know it says x. Don't follow that correctly because you still need the y's to find the eigenvectors. So let's see. So yeah, -3 minus lambda is all of this multiplied by x plus 1 times y equal to 0. So we're just going to solve this. So y, it's going to be -y, take it over on the other side, is equal to -3x minus lambda x. Remove the negatives from each side, remove this one, so it's going to be y equal to 3 plus lambda x. So now we're just going to sub it in. So we have 4 right over here. I'm just going to write this one in red now. So we have our first eigenvector would be y is equal to -4 would be equal to -x. So because it would be -1 in here, it would be -x. You're going to draw write its eigenvector. So v1 is equal to, open bracket, 1, -1. Best thing to do is put the coefficient of the x here, coefficient of the y here, and that should automatically solve it for you. v2 would equal to, open bracket, we're going to put in -1. So 3 minus 1, that would be 2. So y is equal to 2x. So just write the coefficient down here, coefficient of the y over here, and those are your two eigenvectors. So the equation of the first eigenvector, which is this one, matches with either A or C. So I know that B and D are wrong. Now, what should we do? How should we differentiate? So I should be able to notice, if I'm able to read, that both of them are stable, first of all. Okay. Since both of them are stable, they go to the equilibrium point. The only one, this one goes to the equilibrium point, right? This one goes away from the equilibrium point. And since it goes away from the equilibrium point, then we've got a problem, because that isn't stable, that's unstable. So our answer is A. Back.